Hey everyone, welcome back to my channel Leela WebDev. So, in this video, we will try to dive deep into the network basics. So, something like what is this private address like 192.168.1.1 means, and what are this head network and host portions. So, what is this actually mean? So, we'll try to break down the concepts of this one and about the IP address, MAC address, routers, all these things, how it plays a role in while sending the data over the network. And also you'll try to learn something called as the NAT gateway. What is this one? So that by the end of this video, you'll be able to understand how the internet works at its core. So let's get started about this one. So before that, if you are enjoying these technical tutorials and all those things, the videos which I am trying to post in the YouTube, if you are enjoying this one, hit the subscribe button and ring the bell so that you don't miss any future videos. So fine. All right. Let's start with the basics thing. So let's say that imagine you are having a two networks. Try to open the paint online paint. Let's try to open this paint. Anything. Just I am trying to open the paint here. Let it open. I am trying to make it bigger so that you people can able to see. Let's say that you are having. Imagine that you are having a two networks. So here I am drawing the router. Okay. Here I am trying to draw the router, and here is this is the another network which you are having right now. So this is one network one. So here you will be having the router will be denoted something like this. Me one. Yeah, here. Me do this on the control jet. Little bit here. So let's say that you are having two networks. So this is one router. So router normally defined by two arrow marks like this and two arrow marks like this, something like this. So this one is denoted as a router. So this is called as a router. And this is one network. And here also imagine that you are having another network. So this is also a router. The router is denoted something like this. So this is one router and this is another router which is having different networks. So these both are different networks. Okay. So now you are having two networks and each network has a router. So this is the network one, and this one is the network two. And here you will be able to have the systems connected. So device will be connected to this one. Each one will be assigning a different IP address. And here also you will be having an device. Like this, you will be having a device. So now let's say that this router is something like a traffic cop or the traffic police, which will be directing the data where it needs to go. A router is represented with this arrow circle with an arrow showing it sends and receives the data. So that is the main thing which you need to understand. Each network has an IP address and a network mask. So example, let's say that network 1 has an IP address starting with 12.43. So this is the network which is starting with 12.43, and whatever it is, and its network mark is by /16. So this is the so that means 2 bits. So this is all the is a network portion. That /16 means that the first 16 bits of the IP address 12.43 are reserved for the network portion. The rest of the bits are for the host portion. So that means here it should the things will be 12.43.0.1 and 12.43.0.2. Let's issue. Okay. The rest of the bits are host portion, which identifies the specific device on the host network. So any device connected to this router will have an IP address something like 12.43.0 followed by the two numbers between 0 and 255. So like 12.43.100.12. So like this. The network portion tells us which network the device is on, and the host portion tells us identifies the specific device. So that is the main thing. So the device with that IP responds the device with that IP. So here you are whatever the device with this IP will respond with its MAC address, which is like a unique ID for the devices on the same network. Think of it as a device fingerprint, but only used within its local network. So here the device will be communicating with the router in the same network using this MAC address. So once the sender gets the MAC address, it sends the packet directly to the device using switches, which is like traffic directors within the network. So we'll try to see. So sending data to a different network. So first of all, we need to send data to a different network. Now, what if the device is on the network 1? So here this is, let's say that this device wants to send a data to a different IP address, something like, so this is the router 12.41. Something like 0.1. So this is the network which will be assigned to the router, and this one is having something like 12.41.0.5. So I want to send data to this system, so which is having 12.41.0.5. Okay. So the sender checks the network portion of the destination IP 12.41. So now here it wants to send it to 12.41.0.5, something like that. So now this one wants to send the data 12.41.0.1. So now here the router. So here, so the sender checks the sender. Here this guy is a sender. Sender checks the network portion. Sorry, it goes to the router, and here this is the sender. Sender checks the network portion of the destination. So here it will check the network portion of the destination. That is nothing but 12.41. So its own network portion is 12.43. So they are different network. This means the destination device is on a different network. So in this case, the sender sends the packet to its router. So here, yeah, okay. So here the sender sends the packet to its router. So now what it will try to do, the router looks at the network position 12.41 and checks its routing table. So here it will be having its routing table, and it checks its routing table, which is like a map of all the network it knows about. The router says, oh, so I have found this 12.41 is handled by another router that I know about, this one that I am connected to. It forwards packet to that router. So it will be forwarded packet to this router to the internet cable. So which has the IP address 12.41.0. The second router sees that the destination of this 12.41.0.5 is in its own network because the network portion matches. Now it's the same process as before. The router sends an ARP request. It is connected to its connecting devices. So it sends the ARP request connecting to this one. So now what it will try to do? So this one is called an address resolution protocol. So this one we already discussed about this one. So now what it will try to do, ARP request. ARP request. So who has the host portion 0.5? So 0.5. So it will try to check who has the host portion. The device with that IP responds with its MAC address, and the router forwards that packet to that device using switches. So that is the main thing. So what will happen if you are sending data within the same network? Let's say that your device in the network 1 wants to send a packet to another device with an IP address of 12.43.100.12 or 0.2, something like this. So now let's say that the sending device checks the network portion of the sending device. So which is the sending device there? It will check the network portion of the destination IP address 12.43. Here it will try to check the destination also 12.43, and it compares it to its own network position, which is also 12.43. Since they match, it knows the destination device is in the same network. So it doesn't need to bother the router too much. So they will not go to the router too much. So instead, it sends a request to all the devices on the network asking, hey, who has the IP address 12.43, 100.12. This is done using something called as an ARP. That is nothing but address resolution protocol. The device with that IP responds with its MAC address, which is like a unique ID for devices on the same network. Think of it as a device's fingerprint, but only used within the local network. Once the sender gets the MAC address, it sends the packet directly to the device using the switches, which is like traffic directors within the network. So that is how we will be sending. So here directly it will be sent to the switches. So if it is a different device, means it will go to the router, and router checks that where is the matching, and it will go to that particular router. And again the router checks who has that IP, sends an ARP request, so that the device with its MAC address it responds, and for that device it will be sent through the switches. The data will be transferred. So now here this is how it will be happen if it is in same network, if it is a different network. So let's try to understand about the MAC address versus IP address. So what is this MAC address and what is this IP address? So let's clear up something important. MAC address and IP address have different jobs. MAC address, what it will try to do. So let me. So MAC address are used within the single network. So used only within a single network. So this MAC address. So MAC address is used only in the single address. So which is it's either a private or public. They help devices talk to each other locally within like your home Wi-Fi. So in the home Wi-Fi, so always it will be using with your uh, MAC address only. Once a packet leaves your network, it goes through the router. The MAC address is dropped. That's why the address can't see your. That's why the websites can't see your MAC address. So when it is going outside the network, means the MAC address is automatically it will be dropped. So that's why the websites and all those things when you are trying to access, we cannot see the MAC address. IP address on the other hand are used to navigate over the network over the internet. They have two parts. We already know the network portion to identify the network and the local host portion to identify the devices. So that is the main thing. So which you are able to see it here, the network portion and also the host portion. So that is the main thing. So the IP version 4 addresses are 32 bits long, split between the network and the host on the network mask. So private address versus public IP address, which I want to discuss you about this private address versus the public address. Now let's talk about the private and public IP address, which we have discussed it earlier in our videos. So we might have noticed your device an IP address something like 192.168.1.1 something like this. You will be having it, right? Something like this, or 10.0.0.1 something like this you will be having. So these are called as a private IP address used within the local networks like your home or office. So if you try to see I have connected to the Wi-Fi. So if you try to check about the Wi-Fi settings and if you go here about the details, so if you try to see here about the details and you will be able to see somewhere the IP address for me it is connected is around 192.168.0.107. So this is the IP address which has connected to my Mac. So that is the thing. So like this you can able to see. So in your system also you will be able to see either it is a Windows, Mac or Linux. Private address have a specific range which we have discussed it like 10.0.0.0 to 10.255.255.255 or 192.168.0.0 to 192.168.255.255. So here is the kicker. Millions of devices can have the same private address because they are on a different network. For example, your computer and mine both can have a. So right now I'm having 192.168.0.107, right? So maybe when you are trying to check in your system, so maybe you can also have the same IP address like 192.168.0.107. So that means you and me are having the same IP address, but we are on a different network. So that is the thing. So your computer and mine might have both the IP address, but that's fine because we are on the separate networks. But on the internet, every device should have a unique public address. Your router gets a public IP like 172 dot something like that, which is unique across the globe. So when you search what is my IP address in the Google, so when you search like this, so what is my IP address in the Google? What is my IP address in the Google? So here you will be able to see the IP address. So this is an IPv6 address. So IPv4 address also will be there. So you can able to see the in your Google also. So it shows your public IP address that the one the internet sees. So how does your private IP address connect to the internet? So now right now I am having 192.168.0.17, right, which is a private address within the network. Within the network I can able to access it. So how does your private address connect to the internet? This is where the NAT gateway comes in. That is nothing but a network address translation or NAT comes in. The router. So here the router runs the NAT. Okay, so by default the router runs the NAT, which translates your private IP address like 192.168.1.1 into a public address that internet can understand. So when you send data, so here when you are trying to send data to router to the public, the router swaps the private address to the public address before sending it out. When the data comes back, the router translates that public IP address into your private IP and sends it to your device. This is super efficient because multiple devices on your network, like your laptop, phone, and smart TV, can share. So these all the systems and all those things can share only one IP address, public IP address. This saves a lots of tons of IP addresses, which is critical since IPv4 has only about 4 billion possible addresses. That is one thing. So that's it guys, how the internet works from network and host portions to MAC address, routers and the NAT. Every piece plays a role in getting data from one device to another, whether within its your local network or across the globe. The system keeps everything connected. If you found this video helpful, give it a thumbs up and share it with your friends and let me know in the comments what networking topics you want to learn about next. So don't forget to subscribe for more technical tutorials. See you in the next video. Thank you.